Okay. Yeah, but we're going to take a break, let's say at 10:30. Is that fine?
Okay.
Okay, now we go to discussion D4. You see now that we did the union, and if you look at in the union, what we have done is that we have the set D that has 1, 2, and 6, and then the set E has 1, 3, and 4. So there's an element 1 that is appearing in both sides, in the set D and in the set E. When we took the union, we discarded one of them, we only copied one down. Then you ask yourself, okay, is there a way to get that one that is in both of them? So then the thing that this one in both of them is called intersection. So intersection is given by this one is intersection, is called intersection mathematically. Sometimes it's represented by some wedge, which is like a V upside down. We call wedge in mathematics. Now the question is that how do you define this? So if I take the same set D and then I intersect it with the set E, so if I write it is, let me see, is 1, 2, and 6, 1, 2, and 6, and then intersect the other one is 1, 3, I can't remember what is the number, and 4. Then the intersection, which means one, the element that is actually appearing in both set. So who can tell me what is element that is in both E and D, using both D and E? Can you see anything that is belonging to both set E and D? What is the number that is belonging to both set E and D?
1. It's 1, sir.
It's 1. Thank you so much. So
1.
then that is the D intersect with E. So it's called, it gives you the element that is in both. So you discard the rest. You only take the one that is appearing in both sides. Great. Now the question comes in. I mentioned earlier on when I said the union that if I take the set A and I do union with the set, let's say its complement, I get the original set, which I called it L. The question is that what happens if you do the intersection? You see, when you take the set A and then you add its complement, you get the big set. However, when you take the set A and you take its complement, remember the complement of A is those ones that are not in A. So then you get nothing. So that nothing is called the empty set. Right? It looks like a cube, but it's a zero slashed in the middle. So it's called the empty set. Don't confuse it with this one like this with that. That is the set of rational number. All right. Now, this generally, how do you visualize this? So to visualize this, we usually use something called Venn diagram. So let's say I have a set A. This is a set A. The question is that the set A is everything here. The question is, where is the set A complement? The set A complement is everything that is outside the set A. So that is the A complement. So I'm going to now change my notation a bit. When I wrote initially A, I put it outside. Now A, I'm going to put it inside to say A is everything that is inside that circle. It's not a circle, but usually they call it a Venn diagram. Now the complement of A is everything that is outside A. So usually called the complement of A. So everywhere you can write complement of A is everywhere. That's the complement of A. Now the question is that where is the A intersection, another set, and where is also the union? So you see now, if I take two different sets, earlier on when I took the union, if I take a set that I'm going to just call it, let's say A, I'm going to put the A inside instead. And then if I take another set here, let's say B. When I took the earlier on, there's one that is appearing in both sets. So let's say, then where's the union? The union means, let me take a different color. Everything in red, everything in red is the union. So then let me also write B inside. Everything in red is the union. A union B, everything. So it means that everything in A and in B is the union. Now, there is something else in addition that is in red, then it's going to also take a different color. Where is the intersection? So you see the one that in red, I'm going to take red color. is A union B. So if you have two sets and you try to take their union, then the union is everything that is, as we mentioned earlier, you only remove those ones that are repeating. Now, you see, if let's say I take a set, I'm going to change the color. Okay, let me keep it in red now so that you can, we're going to go to union. A set A, let me take a different example of a set A given by 2, 5, 10, let's say 7. Then I take a set B given by 2, 4, let's say 5, 6, 7, and 8. Now, you see, when I want to do the union, means that if I want to represent it mathematically, or if I want to use it, this A union B, we did that earlier, is going to be 2, 4, 5, 6, 7, 8, I think, and 10. So you see that the element 2 is repeating twice. We did not repeat it. We kept it only once. The element 5 is also repeating twice. We only kept one of it inside the union. The element 7 also we kept one inside. So now the question is that in that Venn diagram, how is that going to work? So you see, I'm going to take a Venn diagram. I'm going to do 2, 5, and 7. Those who are repeating here. Let me see this in the set M. Then they have 4, 6, and 8 that are not repeating. 4, 6, and 8. These are not repeating. Then I do the set B. No, that's the set B that I did. So it doesn't matter which one I start with. So that's the set B. Now I'm going to do the set A. 2, 5, 7, then it has a 10. So I'm going to put a 10 here. That's the set A. Then you see the set A is like this. And the set B is like this. So you see all of it now become the union. You can see that 2 is only written once. 5 is written once. 7 is written once. And the remaining that they are just one, we just repeated them. Now the question is that where is the intersection? I'm going to take this. Guys, have I reached 7? The intersection is this thing here. Those ones that are
Yes,
appearing.
sir, V7.
I've reached 7. Okay, thank you so much. The intersection is those ones that are appearing. Okay, let me stop the recording. That is the fourth discussions. Okay, let's take